This video covers the shear wave velocity test. I recommend you watch this video before you watch the direct simple shear test. Sample prep is pretty much the same. So we'll go over sample prep, saturation, testing, and breakdown. Sample prep for direct shear is pretty much similar to this. So here I am applying mineral oil to the bottom platen. You'll see that bender element at the center of the bottom platen. I have then placed a membrane around the bottom platen and vacuum greased that sort of pedestal where it goes into. And so you can see that I have the membrane pushed all the way down into the groove, and now I'm going to apply more mineral oil. I apply mineral oil so that this ring can fit easily around the membrane without damaging it. You'll find that mineral oil is added to lubricate at each stage. Next, we'll place these shear rings around the bottom pedestal, and these are placed one at a time. So you won't do it all at once. That way you can make sure that there's no gaps in between each. So you saw before there were some gaps in between the rings, and then there weren't. Now we can add our next set of rings and tighten them down in sequence. So you'll see these have screws at the top, and you'll do that in sort of a star shape as you go around. Here we've added another ring on top, and this is where your specimen will sit inside. And so here we have an O-ring being greased with vacuum grease, and it will be placed around this ring up at the top. And the reason we'll do that is because we're going to add another ring on top of that that's going to kind of hold everything into place.
And you can place the other thing on top.
And here's that next ring. You can see those grooves on either side fit right around the rods that we had in place to sort of hold everything in place and make sure that those rings on the inside don't move. It's important to make sure that each layer is flush with the one beneath it. And now you can see we're adding another set of rings. These are the rings that are going to be made to the height of the specimen. So we have exactly 1 inch of rings laid about. We've added our next layer. And that gasket on the inside should be greased with vacuum grease as well. And then you'll begin tightening down in sort of a rotating sequence. You don't want to tighten one side down too much and then not the other. So then we'll fold over the membrane as shown here.
Nice, really good.
And you can see that there's kind of a nice seal on the inside. At this point, we're going to attach a vacuum. And there's a male and a female end. So here's the male end going in. We attached the female end first. I prefer to do the male end first usually, but it doesn't really matter. And then once we turn it on, you can see that there's a nice seal. So in this video, we're adding just a little bit of extra sand to go around the bender element. So that way we can actually prepare a specimen to the exact dimensions that we've calculated our relative density at. So that's what's going on right here. And we'll kind of make it flat, and this is just extra sand, so we'll clean up around it and get all of that residual out. And this is done for the top cap as well, but you might want to wet it to make it stick. Now you're ready to dry pluviate your sand into the mold. And here we had it prepared at sort of a medium dense relative density. Okay, so after we put this top cap on, we pulled up the membrane all the way up here and attached another holder and tightened it down, and we're careful not to have it pinch. And the only thing that this does is it keeps water or anything from escaping that membrane, so it keeps it airtight. And then for the shear wave velocity test, we've got 2 lines coming out, so this one and this one. And you have to be careful because on the top there's a B here, and attached to the shear wave velocity lines. One of these lines says B, and it's not necessarily for bottom, it's just to match this one to this one. So we connected this one. I'll have you hold it so I can see it. And then the other two, there's another line, and then this bottom line here. And it used to say T, but we'll label it. And so it just goes in, and you tighten it. Okay, and so this is not loaded yet, although this does have a weight to it. So we say it's at very shallow depths. The weight of this top cap, it puts about 3 kilograms of weight on the soil specimen. Saturation is performed through the bottom valve of your sample mold and from the de-aired water tank. Therefore, it's important to apply a vacuum to your filled de-aired water tank before starting any of your tests, and then open to atmosphere. This is the bottom valve of your specimen, and this is where the de-aired water tank will be connected. Water will flow out of the top. You can see here we have one side blocked off. And so you'll push water through very slowly to your specimen, and you'll wait for water to start flowing out of the top, and you'll let it throw for about 30 seconds or until you see no air bubbles traveling through the line, and then you can consider your sample saturated. Once you have your shear wave velocity switched to VP or VS, the software should automatically be reading your shear wave velocity. This section covers how to measure shear wave velocity and also how to export your data. There's a file labeled instructions on the DSS computer that also show how to measure the shear wave velocity for your convenience and for your reference while you're running the test. This is a reading of a shear wave velocity test, and here we are measuring the shear wave velocity using the peak-to-peak method. As you can see, the red line, or the red wave, is the wave that is being pushed through the sample, and the blue line is the receiving end. So we're measuring how long it takes to get from one end to the other end of the bender element. So you can measure it by taking a screenshot of the entire screen and also exporting your data through the Tools menu. There are many examples of this on the desktop under the Instructions folder. Once you've completed your test, testing VP or VS or both, you're now ready to dismantle your specimen. And breakdown procedures are similar for DSS as well. Here, I am dismantling the shear wave velocity specimen. This is more in depth and will help you with dismantling the direct simple shear test specimen. As you can see, I am taking off the bolts, and the lines for the shear wave velocity have already been disconnected. Here I am taking off the ring that holds the membrane to the top cap, and I keep them in the same orientation that they were placed. Now I'm rolling down the membrane, and I'll remove the top cap. This is the bender element. Now I remove each ring in sequence. As you can see, I remove them by loosening one at a time on each side. I use a small spatula to carefully pry the rings apart. I leave the screws in each ring and do the same. It's helpful to leave the screws in each ring because they typically fit best and get the best seal if you leave the same screws with each ring that it came with. Here you can see that the height of the specimen was 1 inch, and you can see the sand inside. I'm removing another ring to hold the membrane to the bottom platen, and I'm very carefully prying it apart with a spatula. So now we have the ring with the 6 screws around, and you'll want to loosen these up in sequence. And then I sort of leave them in the manner in which I took them off, so that way whenever I run my next shear wave velocity test, it's kind of easy to tell how I'm going to make my sample again. And so here I'm very carefully removing each ring from the bottom And I use a spatula and I very carefully lift each one off around the membranes. That way I don't damage the membrane as I'm doing this. And now I leave all of my rings together and remove the final piece. And I leave those together as well. And there's your specimen, and you'll want to clean this off really well whenever you're done.